Hello everyone, and welcome to this talk about test-driven development. Test-driven development is also commonly referred to as TDD, so I'll be using this term a lot throughout this talk. Today I'm going to tell you about test-driven development in general, and specifically on how to apply it in Flutter. My name is Pascal Bitrise. I'm a full-stack software engineer, and I've done a fair share of mobile development in my career. I started mobile development back in 2008 on the iPhone 3G, and back then I used Objective-C to write native iOS applications. Later in my career I switched to using Cordova, so using web-based technologies to build multi-platform mobile applications. And about 3 years ago I switched to Flutter, and I could have not been happier. Flutter is a great development platform, and the apps that are created using Flutter, they feel very native and fluid, and there's nice animations. So it's just really a nice experience writing applications using Flutter, and the end result is also fantastic. The apps you can build with Flutter are just great. Now, I'm also the Chief Technology Officer at Cabiza. And Cabiza is a software specialist. We specialize in high-quality custom software. And we do that with a team of about 90 software artisans. And that's a mix of software engineers, cloud engineers, UX UI specialists, product owners, and scrum masters. Basically all the skills that you need to take an idea all the way to building and running it in production. Now, besides Flutter, we use quite a few other technologies as well. For example, we use Java in the backend and also Python. We use React and TypeScript for browser-based applications, and we use AWS and Kubernetes a lot for all of our cloud deployments. We are an AWS certified partner. Now let's move on to the topic of today, which is test-driven development. And first, let's start with what is TDD. TDD is a way of building software that is guided by tests. And this means that you write your test first and then the implementation. And there are a few different ways to do it, but this is the most pure and original definition of TDD. You write your test first and then you write the production code. And it literally means that if you want to write a simple piece of functionality such as this, a calculator that adds two numbers, you always start by writing the test case first. And in this case, there's just one test case that's enough to get you going. But you write this test case first, and only then you write the production code. TDD is also characterized by taking many small steps. And what this means is that you always write just the minimal amount of code to make the test pass. So in this case, adding these two numbers together, in theory, I could just return 2, the hard-coded number 2, and that would already satisfy the test. And that would then force me to write another few test cases that use, different numbers, perhaps edge cases like negative numbers or something like that. But in any case, you always try to write the minimum amount of code just to satisfy the test. And that way you really let the test guide your implementation. And in TDD, there's a mantra that is called red, green, refactor, and those 3 steps you basically always follow throughout your TDD practice. Now let me explain that in a little bit more detail. So we always start with red, and this means that we always start by writing a test case, and initially that test case will fail because we don't have any production code yet. And when we're in this red state, our goal is basically to either turn that into a green state, so make sure that the test is passing, or we want to change the message. Because I said earlier, what we try to do in TDD is we try to take small steps. So we don't have to necessarily go from a failing test immediately to a passing test, but we also can just take one small step to change the error message, run the test again, look at the error message, and then again let the test guide us into what we have to do next. An example of this is we start with a test for a class that does not even exist yet. Well, then the first error message we'll get would be something like class is undefined or class is not found. And then we just create the class, we run the test again, and then the error message will change, and it will say something like the method or the function add is not found. And then again, we do the minimal to just change the error message. So we will define a add function, but we will not let it do anything yet. So then again, the test will keep failing, but again, we will have a different error message. And we will just, complete this process until we have a green test. And then we're happy, right? Because we have a green test, which means that our code is working and our code is doing what we expect it to do. Well, then the next step is to refactor our code. So red, green, refactor. So in the first time when we're just, writing the test case, making sure that the test is passing, we don't care too much yet about the structure of our code, how many functions we have, how many lines in every function. We don't worry too much about the variable names just yet. We just are focused on getting the test passing. But once we have the test passing, then we're going to into the refactor stage. And this is an important stage that you should not forget. Because in this stage, what you're going to do is you're going to change the code in such a way that the behavior of the code does not change, but the internal workings of the code are going to change. We're going to improve it. And if you always follow these steps of red, green, refactor, it's a really nice way of going about it, because writing the test first, making sure it passes, it gives you the confidence that the test is correct, and then you can refactor, improve the code, and make sure that if you run the test again, it's still green. And oftentimes, when you've refactored, then the next step is usually to add more test cases. For the example of the calculator I just shown, it was just one test case. But for a piece of code like that, you will probably write a couple of test cases, because you also want to test some unhappy flows, for example, or you want to test some edge cases, like what happens if we try to add up two negative numbers. Maybe this calculator doesn't support negative numbers, and in that case, we would expect a exception or something like that. Basically, you're going to think about, during the test, you're going to think about how should this code behave, and you're going to write the test cases for it, and then guide the implementation from there. Now that we've covered what is TDD, let's look at why should we practice TDD. And the first thing is TDD helps you design your software. And we typically see that software that is written with a TDD approach tends to be more loosely coupled. And this is because if you're writing tests and your code is very intertwined, so you have many classes that are interacting together, and functionality is spread all over the place, then your tests are going to become a real pain to write. They're going to be difficult to set up. You will have to mock or stub a lot of dependencies, and writing the test will just not be a nice experience. So just the act of writing tests, it makes sure it improves the modularity of your code, because otherwise writing the tests will be very painful. Also, automated tests help you catch regressions, because we're always writing our test code first and then the production code. If we always do that, then we automatically build up an entire test suite that will help us to verify at any given time that the software is still working the way it was supposed to be. And this has a pretty profound effect on the quality of software over time. We typically see that teams that don't have a test suite in place, when time goes by, the quality of the code usually goes down, because people, when there are no tests, no automated tests, people tend to add new code instead of integrating code into the existing code. So you end up with a lot of code, a lot of boilerplate, because if you don't have a test in place, then if you're adding new code, you never know, or if you're changing code, you never know if you're going to break something. And just having the test in place gives you a lot of confidence, because having a test suite in place gives you the confidence to make changes, to integrate new code into your existing code, to refactor things, to improve it, because you can always just run the test suite, and in a couple of minutes, you will know for sure if you haven't broken any code. So this is really, really a big benefit of using the TDD style. It usually really leads to higher quality code. But it's more work is something that people often say to me, and my response then always is, well, is it? And I do think that TDD is an investment, because yes, you're going to write more code, but it's an investment that pays off pretty quickly. We oftentimes see that, in the first couple of weeks of a project, if you don't practice TDD, you're sometimes going a little bit faster than if you are practicing TDD, because in the beginning, when you're approaching with TDD, you have to do some setup, making sure that you can run your tests in CI, making sure that you can, mock out or stub a database or API calls. So there's a little bit of investment there, but it pays off really quickly. In a couple of months or a couple of weeks even, you're already going to see a lot of benefits of having the test in place. And yes, you do have to write a little bit more code because you also need to write the test cases. But I would say that if you become more experienced with TDD, then it's just going to be a second nature. And I think that by now I'm just as fast writing my test cases and my production code as doing it without it, because the test really helped me so a lot to produce the code that I need. So yes, it's a little bit of an investment, but I think it also saves a lot of time. So probably net, I'm going to say that it is going to be beneficial and will reduce the cost. And this is because it will save you time during development. Especially if you're working on a UI application, such as a mobile app, if you're working on some functionality that is, somewhere deep in the app, you first have to log in, you have to go through a few screens. Then if you don't have a test suite in place, you need to do this, these steps many, many times during development, just to verify that what you're building is actually working. And if you have a test suite in place, you just write the test, and then you start coding, and then you use the test to verify that the functionality you're working on is actually working. And then still, of course, even if you have an automated test suite, there's still a little bit of manual testing involved, but it's a lot less. You just test once or twice probably with the actual application, and everything else you just test using your test suite. So it will save developers a lot of time during development. And also, in general, you just spend a lot less time refactoring or reworking or fixing code, because you can catch a lot of bugs already much earlier in the process. If you have your test suite in place and you break something, you will know it even before you check in the code. So, and at that time, it's a lot easier to fix it than if a week later someone finds a bug on your test environment. So that also there you save a lot of time just spending less time on fixing code. Now, who should write these tests? Well, and the answer is simple. It's developers. And the reason is what I explained. TDD, writing tests, it is really about both having the test suite, but also, and even more importantly, about designing your code. So writing the tests helps you design your code in a very modular and loosely coupled way. So that is why developers should write their own test cases. That doesn't mean you cannot have a QA team or a product owner that's going to do some manual or exploratory testing, but still developers should write their own tests so that you are in charge and you can make sure that your software product is still working at any time the way it's supposed to work. Now let's look at the different kinds of tests. There are different kinds of tests that we can write. And this is usually explained using the test pyramid. And the test pyramid, it basically shows us a couple of things. It shows us that we have different kinds of tests, and there are some different names in the industry in use, so don't get hung up on these test names too much. But generally, at the bottom of your test pyramid, you have the unit tests. And unit tests, they are tests that will test just one small unit. And that's usually one function, one method, or one class. And it will test just that one single unit in complete isolation. The benefit of this is that it's very fast. You can execute to hundreds or even thousands of unit tests in just a couple of seconds, because they don't have any dependencies, they don't interact with a database or a file system, they are just pure business logic. And the next layer in the pyramid is the service test layer. And the service test is basically a test that tests a couple of units in your system together. And you might think about something like a service class that, for example, makes an API call to an external system and then saves the results in a database and then returns something. And this is an example of a service test. You combine a couple of units and you test them integrated together. And then the top layer of the pyramid are the UI tests. And the UI tests are basically the kinds of tests that are the most integrated, because they will test your system as a whole. And it will test this system exactly the way that an end user will interact with the system. So if you're building an API, then the UI test will be a test that actually calls REST API calls or GraphQL API calls. Or if you have a mobile app, then the UI tests are actually going to install the application on a mobile device, an emulator, or a real device, and it's going to actually interact with the application. It's going to click and scroll and swipe and everything that a real user would also do, but then in an automated fashion. And all these three kinds of tests, they are important because together they will cover all the functionality in your application. And what the pyramid also signifies is that the unit test at the bottom, that's where you have, it's the broadest layer of the pyramid. And that's where you want to have the most tests because they are the cheapest, they are the fastest to write, the fastest to execute. So anything you can test on the unit test layer, you want to test there. And then the other layers, you're going to have a lot fewer tests of those because most is already covered in the unit test layer. And in the other two layers, you just want to test the things that you cannot test in the unit testing layer. So now that we have looked at TDD in general, let's look at how we can apply TDD in Flutter. And we're going to do that by looking again at the test pyramid and seeing how it applies in Flutter. So the first layer is the unit test layer, and in Flutter we have two kinds of tests that you could call a unit test. And the first one is a Dart unit test. And a Dart unit test is basically a, really traditional way of a unit test. It's just going to test your business logic. So it's just pure Dart code, pure business logic. And the second kind of unit tests are widget tests. And widget tests are, again, they are isolated tests, similar to a traditional unit test. But in this case, you're testing an actual Flutter widget. But it's just going to be one very small, tiny part of your user interface. For example, think of a card widget that takes a user object and then shows an avatar and the first and last name of this user. For that, you can write a widget test where you just pass in a user object and then you're going to render the widget and you're going to verify that, for example, on the left, there will be an avatar and on the right, there will be a first and a last name. So this is an example of a widget test in Flutter, and it's also a kind of unit test because it just tests this one small isolated part of the application. Now let me show you some example code. Let's say we want to build a calculator, a very simple calculator. Then the first step would be I'm going to create a test file. I'm not going to start with the production code, but I'm going to start with the test code. So I've created a calculator test file here. And then I'm going to start writing the code I wish I had. And I wish I had a calculator class. So I've written this code. And now if you remember the red-green refactor steps, then we're now in the red stage. Because I've written this code and it will not even compile. So if I now run this test, then the test will be red because the calculator class does not even exist yet. So now I'm going to do the minimal amount of work to make this test either pass or change the message. And in this case, the minimal amount of work that I can do is I can create a calculator file, I import it, and in the calculator file, I'm just going to create an empty class called calculator. And this is all that is needed to change the error message. So I do this, I run the test again, and in this case, the test will be green because all that this test is doing right now, it's just creating that an instance of that calculator class. So I'm done here. Moving on, I'm going to write a test case. And in this case, I'm going to write a test case that tests that when I call the add function and I give it two numbers, then I expect that this will add up the two numbers. And there are a couple of things to notice here. First, I'm using the test function here. This is part of the Flutter test framework. I give it a test description. And this is quite important to think about a good test description because the descriptions of tests, they are a way or a form of documentation. If you are new into a code base and you want to know how it works, then just going through all the test cases is a really good way to understand what the code is doing. So I write a test description here, and then again, I'm going to write some code I wish I had. So I wished that my calculator class had an add method that I could pass two numbers, and I'm going to write an expectation. So I expect that when I call calculator.add with 1 and 1, that the result will equals 2. Now, if I run this test, it's going to be red. The first time it's going to be red because the add function doesn't exist. And then I'm going to follow the small steps again to eventually move into a green test stage. And then I'm going to refactor the code. But for now, I'm going to move on because this was just to clarify the point. Now then, let's look at an example of a Flutter widget test. And just to give you a little bit of context, the widget test that I'm going to show you is going to test this widget over here. It's a pretty simple widget. It has a static count label. It has a label that shows a counter value, and it has a minus and plus button. And if you click the plus button, it's going to increment the counter by 1. And if you click the minus button, it's going to decrement the counter by 1. And again, the process is exactly the same. And let me just move myself out of the way. And basically here, I'm just not going to use the test function, but I'm going to use the test widgets function. And this is, again, something that Flutter provides you to write these kinds of widget tests. And there's a little bit of boilerplate code here, but the important part here is that using the pump widget function, we can render our widget in a test environment. So in this case, my widget is called counter. I can render it, and then I can do verification. So in this case, I expect that if I just create a new counter widget and I render it for the first time, and the user has not clicked the plus or minus button yet, I expect that a placeholder is shown, just a minus text and nothing else, because there is no 0 or 1, there is no count yet. And then I'm going to move on. I'm going to create more test cases. So for example, I want to test that if I tap the plus button and render the widget again, then I expect that a 1 will be shown, because then the counter should be increased from nothing to 1. And this is just going to continue like this. But what I also wanted to show here is that the red-green refactor, it applies to both your production code as well as your test code. So in this case, I mentioned before, there's a little bit of boilerplate here that Flutter requires when you render a widget, and it makes a test a little bit more difficult to read. So I'm also going to refactor my test to make it more readable. And I do that in this case by extracting a render function. And then you can see in all the tests that follow, I can just use this render function and the test will become easier to read. And then I can add a third test case where I can do some more interactions, tapping a couple of times, and then again verifying that also the decrement functionality is working. So moving on, we've now seen the unit tests, we've seen the widget tests. Then in Flutter you can also write service tests. I don't have an example of this, but a service test is very similar to a unit test. It's just that in a service test, you test multiple units together. So you use exactly the same test APIs, but you're using multiple classes together instead of just one. Then the next one is more interesting, and those are the UI tests. And this is very important in mobile applications, to be able to write tests that actually exercise the application as if you were a user. And Flutter also comes with support for integration tests out of the box, and this is called the integration test package. And let me show a little bit of code. You might see here that and that's the nice thing, the API to write these kinds of UI tests in Flutter is exactly the same as the widget tests. The only difference here is, if you look over here, I'm calling app.main. So basically I'm going to just boot up the entire application and not just one widget. But then I can use the exact same APIs. So I can pump, render the widget, I can tap, I can scroll, I can swipe, and I can do all these verifications that I can also do in a widget test. So that's really nice. You just have to learn one test API and you can use it to both write these isolated widget tests and you can use it to write UI tests. I'm not going to go into too much detail, but I am going to show you what this looks like. So let's see, if we run these tests, you see that we'll launch the actual application and it's going to interact, in this case, with the buttons. Now that's all. In any case, if you have any questions, then I'll be happy to answer them, and feel free to reach out to me. Thank you and happy TDDing.